In this video, I'd like to continue talking about the amplitude of sinusoidal functions from their equations. And in a previous video, we looked at the parent function for the sine and the cosine. And we saw that when we multiply this parent function on the outside by some constant a, then this constant essentially stretches or scales the function by whatever that factor is. And if a is bigger than 1, then it will stretch it. It will make the amplitude bigger. If it's a fraction, then it will shrink it. It will compress the function. And if it's negative, it will reflect the function over its midline. But if it's negative, that doesn't actually affect the amplitude. So what we determined is that the amplitude of our sinusoidal function, it can be sine or cosine, is the absolute value of this coefficient here, this constant a. So when looking at the sinusoidal equations, these are more complicated, of course, than our parent function here, but we're essentially just focused on what are we scaling the function by? What are we multiplying the sine or the cosine by? And in this case, we can see that we are multiplying the sine function by 7, meaning that we are stretching the function by 7. Its amplitude is 7 here. It's whatever this number is on the outside of the sinusoidal function that is multiplying the function by. And it's the absolute value. But in this case, the absolute value of 7 is positive 7. But when we look at this cosine function here, it's multiplied by negative 5 on the outside. So in this case, we are stretching the function by a factor of 5, but it's also reflected about its midline. But again, with the amplitude, we're concerned with the absolute value. So in this case, the amplitude is the absolute value of negative 5, which would just be positive 5. So the amplitude here is 5. And in later videos, we will talk about what is happening on the inside here. This is essentially related to the period. And this number right here that we're adding or subtracting, that will essentially shift the function horizontally, either left or right. And this plus 6 on the outside, or minus 2 down here, this will essentially move the function up or down, depending if it's positive or negative. And in this case, it will move it up 6 units. But this will deal with our midline. Adding or subtracting on the outside of a function, remember, just shifts the function vertically. And in this case, since we are subtracting 2, this will shift the midline down 2 units. But again, for the amplitude, we're really just concerned with what are we multiplying the function by. So let's look at a couple more examples. We have this function g of x, which is the cosine of 2 pi over 3 times x plus 1. Again, the number on the inside that's multiplied by x, this will affect the period. This will cause horizontal stretching or shrinking. And the plus 1 here will cause vertical shifting. It will move the entire function up by 1. Essentially, all the y values of the function values have 1 added to them, so it shifts everything up 1. But for the amplitude, we're concerned with what are we multiplying this function by on the outside. And since we don't explicitly have a number here, we can assume that we're just multiplying by 1, meaning that in this case, the amplitude of this function is 1. And of course, we could check this on a graphing calculator. If you plug all this in, you will see that the distance from the midline, which will just be y equals 1, to either the maximum or the minimum point would just be 1 unit. Let's do one final question. And for this one, we have minus 4 times the cosine of 5x minus 9, and then we are subtracting 7. The minus 7 on the outside shifts us down 7 units. The 5 affects the period. The minus 9 causes a horizontal shifting. And the number that we're multiplying the sinusoidal function by, this affects our period. And this affects our amplitude. And for the amplitude, in this case, we have a negative number, but remember that the negative just causes a reflection about whatever the midline is. In this case, the midline is y is equal to -7, but the reflection doesn't affect the amplitude. So we are actually just looking for the absolute value of this coefficient out front to find the magnitude of the amplitude. It's always going to be a positive number. And in this case, the absolute value of -4 is simply +4. So the amplitude of this function is 4 units.